Right, SSH can also work. But what about R3? You still need to configure it, right? Although the command isn't much. What if you have 100 or 1000 devices? Right? When there are many devices in our network and many network administrators, each person having an account, then configuring locally, doing local configurations makes the workload very, very large. So at this time, we should avoid configuring local authentication as much as possible. So we say a company has 100 switches and routers, 3 network engineers to maintain. If traditionally the traditional way is local management, then we have to create authentication information on 100 devices. Honestly speaking, right, it's tough. You have to create 3 accounts per device on each of the 100 devices. It's quite cumbersome. It's quite a hassle. Secondly, if it's an operator and they have 10,000 dial-up users, actually, 10,000 users are already few for an operator. At that time, think about how many routers an operator has. If you had to save all this information on the routers, how would you manage that? It's unmanageable. And also, operators, right, have a service called mobile base, where you move a broadband from AD to BD. If it's local authentication, you have to delete the account from AD and add it to BD. You tell me, isn't it easy to mess up? It's very easy to mess up. Of course, it can't be managed. And also, as we mentioned earlier, if we have 100 switches and routers maintained by 3 network providers, then today, if Zhang joins, wouldn't you need to create a username and password on 100 hosts? And then, let's say tomorrow, Zhang gets arrested, then we have to go and delete Zhang accounts from these 100 routers, right? The outlaw Zhang was arrested, and then he resigns, and then Li Si joins, and we have to go create accounts on 100 devices again, one by one. Isn't that troublesome? It's too hard. So if you say 1 account per person, it sounds very troublesome. If you use 1 account for everyone, it's not safe, right? Why? Because everyone uses 1 account, that account will definitely be leaked because you can't trace responsibility, right? So of course, I secretly tell you, right? Others also don't know it was me who told you. So they can't pursue my responsibility with just 1 account. So if there's a fault later, you can't find who's responsible, who did it, right? Which person deleted files and ran away. With 1 account, you wouldn't know. So at this time, we need to introduce something called 3A. So the so-called 3A, local authentication, should be called local management. And also, through what? 3A management. 3A, in terms of local management, it means that user information is stored locally. Local management should be called local management. And also, through what? 3A management. 3A, just local management, it means user information is stored locally. Not right, it's login information, login credentials stored locally. And the other is 3A management, which includes authentication, authorization, accounting. Authentication is identifying who you are, authorization is what you can do, accounting is what you have done. 3A is a service that involves authentication, authorization, and accounting. 3A involves these 3: authentication, authorization, and accounting. Authentication here means it's about identifying who you are. Authorization is about what you are allowed to do. Just what can you do? Auditing is about what you have done. So if we go through 3A management, it needs a server, a 3A server. This means here, the user information is stored on the 3A server. User information, user credentials stored in on a 3A server. This is 3A management, where user credentials are stored on a 3A server. And this 3A server manages the user credentials uniformly. Let's write that down. By the 3A server, uniform management. In this way, we only need to create accounts on the 3A server. You don't need to create them one by one on each of the 100 devices. Right, this makes the process much more convenient. And it can help us with user authentication. Which user wants to log in and what permissions this user has. We can assign different permissions to different users. Then it records what each user has actually done. So 3A for authentication, authorization, and auditing. This means if we have many devices or many personnel or frequent changes in personnel, we recommend using 3A for management. Okay, whether it's console ports or VQI interfaces, we can integrate 3A. We can implement with 3A what we discussed earlier about login. Login, no login, login, login local. No login means no authentication. Login and login local are both local authentication. We can also avoid local authentication. We use a dedicated authentication server, more accurately called a 3A server. Why do you say authentication server? It only has one A, right? It's not just about authentication, it also includes authorization and auditing. We can manage user information through a 3A server. All users go to this server for authentication and to receive authorization. All users authenticate on this server, receive authorization, and it will record what these users have done. This is 3A. Then 3A server, it centrally manages user credentials. Network devices do not need to manage user information themselves. User credentials are sent to 3A to be authenticated and authorized centrally. 3A, of course, supports local authentication, because what if the 3A server goes down? You can't say that if the 3A server goes down, the whole network goes down. If the 3A server goes down, the entire network would be down. That would be very dangerous indeed. So, configuring local management through 3A is only a temporary fallback plan. It's like an escape plan, right? This means we can implement with 3A, and the content about 3A is quite extensive. We will have a section later to specifically discuss how to deploy 3A, what 3A is, how to deploy it. This includes NP and IE content. 3A's concept is to include authentication, authorization, auditing. You are who, right? Identify users through their credentials. Secondly, authorization assigns permissions based on identity. Thirdly, auditing records events. Who you are, what you can do, what you have done. Authentication, authorization, counting, the 3A's. Then 3A is just a service. 3A is a service. How is it implemented? How do you implement it, right? Here, 3A, how do our network devices communicate with 3A? You say we have these 100 routers. How do they let the 3A server help them authenticate? There are two protocols inside, one called Radius, one called TACAX. Radius is a public protocol. It is based on UDP 1645. How is it implemented, right? Here we're talking about 3A. How do our network devices communicate with 3A? Consider our 100 routers. How do they request authentication help from the 3A server? There are two protocols involved. One is called Radius, the other TACAX. Radius is a public protocol based on UDP port 1645. TACAX, on the other hand, uses a different protocol approach. Or it goes like this. It has two sets of port numbers. For authentication and authorization, it's 1645. The old port is 1645. The new port is 1812. For accounting, the old port is 1646. The new port is 1813. So 1645 and 1646 are one set of port numbers. 1812 and 1813 are another set. You can choose to use the old ports, or you can use the new ports. In this case, when it comes to Radius, it is a public protocol. When do you use a public protocol? Often it is when devices from different manufacturers need to interact. At that time, public protocols are typically used. like when a computer wants to connect to the network, and it is required to authenticate if your computer and your switch aren't from the same brand at that time. When devices from different manufacturers interact, your computer, often with your switch not being the same brand at that time, different manufacturers' devices need to interact. Then in such cases, we generally use the radius public protocol, and TACAX is actually only used for device management. Why? Because you see, if you want to manage, for instance, manage Cisco's network devices, you want to manage Cisco's routers, switches, firewalls, and other devices. You, of course, generally speaking, our 3A server also uses their own. So in this case, all devices are from the same manufacturer. It can use a private protocol. Public protocol, its advantage is good compatibility. The feature of a private protocol is that it can be modified as desired, more flexible. Because a public protocol, its rollout, well, a public protocol, you need a protocol to become a standard, or you say, your protocol development. Or what is it? It's your protocol development. It's especially easy. Then people want to use it. Then you release it for others to use. In that case, of course, you say this is called publicization, right? Publicization. In that case, of course, it's up to you to decide. But the process of publicization, in that case, of course, you have the final say. But its process of becoming public definitely involves, well, in that case, various manufacturers, right? Various organizations, then various that going to that meeting to set standards. That is to say, you can't just change it whenever you want. Changing it is rather troublesome, right? Then with a private protocol, you can change it however you want, right? After you change it, just update the version number, right? In that case, that is to say, if we are managing networks and the whole field is Cisco devices, we will use the TACAX protocol for management. Then with 3A, it involves two protocols. One is radius, the other is TACAX. Of course, these two things, exactly when to use radius and when to use TACAX. Here, you just need to know network management uses TACAX, others generally use radius. That is to say, you need to know these two things. As for how to configure this section, we will discuss this further in the NPIE phase. As for Cisco, its 3A server has two versions, one called ACS and the other called ISE. ACS is this, secure, which is basically, ACS is actually access control server. But this name sounds quite commonplace. The name access control server, access control system, these names are quite commonplace. But this product, the previous Cisco 3A server was called ACS, but it has now been discontinued. Why? Because currently, Cisco has a product called ISE, which is Identity Service Engine. Identity Service Engine covers all the functionalities of ACS. Therefore, ACS no longer had a reason to exist. Now, Cisco's 3A server is called ISE, which foreigners like to call ICE. This thing, Identity Service Engine, the early versions of these two products did have some differences in functionality, but ISE developed to version 2.0 and then covered all the functionalities of ACS. Thus, ACS was discontinued. A 3A server will always maintain its own maintained database, which will store saved user credentials like usernames and passwords, such as authentication and authorization policies, audit records, including some of that log information. Those things are in the 3A server, right? It will uniformly maintain just the user information and also authentication and authorization policies, including some of those audit records, of course, user information. It can also call an external database to provide user information like in our corporate network, like in our company. User information is usually stored where? Stored on a Microsoft AD. Just deploy the Windows Server system, then install AD services there. On this server, I create usernames and passwords, right? Then add all the hosts to this domain to enable domain account logins. These domain accounts are what we use in our everyday work. Domain accounts you think at that time, right? Then do we need to create another account on this 3A server again? Honestly, after creating it, the experience isn't great. Why? Because of the password policy, our passwords need to be changed regularly. If you have an account on the 3A server, an account on AD, and then another account somewhere else, when it comes time to change passwords, you have to change each one individually, which would make for a very poor experience. Thus, we can call the accounts from AD to improve the user experience. So I have just one password, right? When I authenticate in the network, it's also my computer's startup account. That would be better. So the 3A server can also call external databases, which means this 3A is a service. It must have a server called 3A server. It serves to manage user information centrally. It must maintain a database for this purpose. Through this 3A server, using the 3A server to centralized management, specifically centralized management of user credentials, then providing services like authentication, authorization, and auditing. So the 3A is a type of service providing authentication, authorization, and auditing. Okay, so here what we are saying is this 3A is something we are currently understanding. And moving forward, we have a command called command level, right? So about command levels, we've actually mentioned it before, right? Regarding permissions, it is designed from level 0 to 95. So what can only level 0 do? It can do enable, that is the enable command, right? I want to elevate permissions, and the disable command, I want to give up permissions that are at level 0. At level 0, well, at this time, level 0, actually when we come in, we see show privilege. We can see it is already level 1. Level 0 permission is almost non-existent. Level 0 only has 3 commands. Not correct. Just here. 1, 2, 3, 4, 5 commands. These commands, exit, and disable. Honestly, log out, this you can ignore it, right? Log out, this exit. Just exit, disable, right? Just give up permissions. These 3 commands are not any effective commands. In the end, he can only enable and help. But at level 0, it almost doesn't exist. So besides him, the lowest level is level 1. Level 1 has a very distinct feature. Its prompt is not a colon. This mode is level 1 permission. So at level 1, you can only do some limited viewing commands, that is non-sensitive viewing commands. You can pick these level 1 permissions, like show version. Let's see what version it is, right? You say, I'm going to show IP interface, brief, I'm checking the interface. You say, I'm going to show IP route, I'm checking the route, and so on. These, you see, non-sensitive commands. You can type, but you say a bit sensitive, can I show run? Sorry, show run can't, because show run is considered sensitive. Show command, what to do then? It requires level 15. Then by default is level 1, right? Level 1 is user mode, and then levels 2 to 14. Levels 2 to 14 are empty, reserved, actually just empty, there's nothing. Levels 2 to 14 have nothing, no difference from level 1. So, he is like this, that is to say, why set up such logic? This logic is like this, that is, high level, high privileges mean high level. High level means high privileges. High privileges allow use of lower privilege commands. The logic is like this. You're like level 15, right? He can use commands from levels 2 to 14, and then like you are level 2, right? You can use level 1 commands. That is, for example, level 15. can use commands from levels 2 to 14. And then you, being level 2, can use level 1 commands. It's set up so that you can use the commands from the level below yours. If there are commands for level 3 can use commands from levels 1, 2, and 3. Then, level 15 can use commands from levels 1 to 14, including level 15's own commands. This means that higher levels can use the commands of lower levels, but lower levels cannot use the commands of higher levels. Lower privilege cannot use commands of higher privilege. This means at the user level, we can easily categorize users into different tiers. We can assign different permissions to each user. Here, levels 2 to 14 are reserved for us. Level 1 is called user mode, indicated by this prompt. Through the enable command, you can enter what's called privileged mode. Privilege, of course, for levels 2 to 14, is also indicated by a marshmallow sign. So, normally people don't access levels 2 to 14, so we assume when we see this Nivagam sign, it usually means they are at level 15. In privileged mode, the prompt is a e-mother sign, and you can execute all commands. What does privilege mean? It means you can use any command, including modifying configurations and even account settings. Levels 2 to 14, however, are undefined and are reserved levels. By default, they are the same as level 1, so users can delegate commands to any level. This way, we can assign commands to levels that normally wouldn't have access. This allows us to give lower levels access to higher level commands, so we can delegate commands to other levels. Because by default, some configuration commands and even some sensitive show commands are only available in privileged mode. But here, privileged mode can access everything. And we say, of course, when you authorize, we must know one thing. We should do if there are many administrators, then each one should only have necessary permissions, just the necessary ones. From a security perspective, we grant permissions always minimizing permissions. That is, other than necessary permissions, we do not grant any others. It's a safer management measure. Our security approach is always to minimize services, always ensuring security through minimal services, always crafting a minimalist service approach, minimizing services, providing only what is needed, only what is required by others. We provide what they need, and here, using command levels, with these command levels, now let's say on R2, I log in with control, right? What mode is it in? It's in level 1, so I do this, I go to line console 0, and I type privilege level 15. Now, on the console, I grant it privileges, level 15. Now at the console, I give it, say, user level is now 15. Now I go back and come back in, and come in again. Log out, go out, right? Then I log in again, directly at level 15, right? Okay, so if I do this, I go to line console 0, and I set the privilege level to, say, 10. Log out, then log in. It's a teens level, so not just any privilege mode is indicated by a navs, actually. It's not just a navs. In reality, we also have teens level, and at this time, you'll notice there's no navs. You can't type configure afterwards. You can't type because it doesn't have the command. We need to enable it. If we enable it, enabling usually grants level 15 privileges. So here, starting from level 2, the prompt is a non-ifs, but usually no one proceeds to enter other levels afterward. So this means we can set privileges, right? If you're doing this kind of you're doing this kind of non-authenticated or offline authentication, your user level is typed under this line, under line console, or say line VTY typed under this line. But if you're a user, if you log in as a user, then here, the line's permissions, its permissions are configured on the user. For example, username admin2. Here, privilege, like his privilege, for example, is level 10. Privilege level 10. Usually no one adjusts it to level 10. For example, his permissions are level 15, right? We call it this, super admin. His permissions are level 15, password Cisco. Okay, now here we have two users. Here we have two users. Default is level 1. Default is level 1. This means other levels. This place will tell us. Now, if we use this super admin login, he's directly super admin. After logging in, he's directly level 15, right? To come out after that, if I use admin to log in, here he's level 1, right? Of course, we can use the enable command. To centralize, of course, just use the enable command. At the console port, you can type it directly. No problem. But if you go through the VT code route, this time you type enable, he will say you haven't set a password. Remotely, you want to type enable. You must have a configured password. Why does enable by default not have a password? Because it's for the convenience of initial configuration. So this time, our permissions, if it's offline authentication or non-authentication, we type this privilege under the landline. If it's local user authentication, you type it behind the username. Add a privilege. You set a level for yourself. This way we can log in. This way we can set access levels and log in. Once logged in, this refers to the command authorization level. Typically, the commonly used levels are level 1 and level 15 for user mode and privileged mode. If you want to enter the global configuration mode, you must have level 15 privileges to enter. Without level 15 privileges, you cannot enter. In this mode, okay, so if, a user wants to access other privileges, we can use the enable command. But to use the enable command remotely, you need to set a password. So how do you set a password? You configure an enable password. For instance, something like Cisco. Once set, at this point from R2, I can telnet to 12.1.1.1, access it remotely with the admin account and Cisco password. No mistake here, we're prompted to enter the password Cisco to log in, and then we enter what? Privileged mode, come out. But honestly, when you enter privileged mode, honestly speaking, when you check the line, what do you think about the security of that enable password? Is it secure? Not at all secure. So what do? In this case, after you've seen this password, hey, it's not secure. This password also not secure. So what do? In this case, use enable secret, which is an encrypted password if we set the password as wolf, for example. Now this password is encrypted and we can't see it. So the password is displayed in plain text in the configuration. So if someone is standing behind you when you're configuring and you run show run, your password might just be leaked, but with secret. Even if someone sees it, it's useless. They don't know what your password is, but if you have both password and secret, secret takes priority. When you telnet in, you'll need to use wolf, and that way your password security is ensured. No one knows what it is. And if you have both password and secret, secret is prioritized, so the password becomes redundant configuration. No enable password Cisco, and our username and password. What do? For the username admin, add a secret. Set a level for him. Like this, of course. For telnet, we can capture packets. We've already started one. Let's close this. Hey, take a look at this. I'll first test. If packet capture is on here, I'll ping 12.1.1.1, see if I can capture the ping. If I can, then I'll telnet. 12.1.1.1. Enter the password later. What's the password? Cisco, then enable. This time, I'll type wolf. Then we can track the flow. Track the TCP stream. Hey, the password is wolf, right? If you simultaneously have Cisco and both password and secret takes precedence, then what becomes of the password? It becomes junk configuration. No enable password Cisco. Well, our username and password, right? What do we do then? Username and password. Username, for example, admin. Secret, Cisco. The secret command uses encrypted passwords. If you're setting it, you can be sure it's secure. This approach ensures that the password is relatively safe. Oh, they can't have both at the same time. We have to delete the username, admin, then create username admin, secret Cisco. Over here, we can see what we configured. Username, password. The same with this account. This account is also the same. We remove super admin, remove username super admin, then username super admin, privilege 15, secret Cisco. In this way the key is relatively safer, right? No one knows your password. So in this way, when you show the configuration, no one standing behind you can use it. To log in, it's the same. You can log in. We go telnet, right? 120.1.1, password account admin, password Cisco. To be honest, right? Telnet is still not secure. You say track the stream. Once tracked, again, track the stream. One look at it, everything is visible. So we suggest using what? Use SSHL admin. Here is 120.1.1. In this way, if you use SSH, relatively speaking, others don't know what you are sending. In this way, it is relatively safer. People just don't know what you're doing. In this way, it is relatively safe. It is slower though. This simulator is slow. Too slow, right? Password Cisco. In this way, we SSH up. Then when SHing up, you have to go, haven't caught the packet? Haven't caught the packet. Actually, we just captured it. This place, if it's SSH, the packet's captured, right? They say it's encrypted. In this way, it is this way it's safer. Then enable, right? If we want to use the enable command remotely, we must add a password. The password, secret, is the encrypted password. Password is the plain text password. In this way, when you type enable, you can type enable, right? The default typing enable is like typing enable 15. Enable 15. Enable 15 means entering level 15. Of course, you say I want to enable 4. In this case, that's level 4. When we create users, right, we can directly specify what level this user is. His user level. So after you log in, you directly get that level of permission. Then if we are in a certain thread, right, like line console or line B2I below, we use privilege level 15. Then in this case, it's like saying, if you don't authenticate, meaning you don't use authentication, or when you perform offline authentication using these methods, we set provision level 15 under this line. In this way, if you come through this line, everything is at level 15. Of course, the best way is to use 3A for centralized authentication and authorization. In this case, honestly, we use 3A to allocate user permissions. What do we do with 3A? User level authorization. Of course, we can even do command authorization. So in this situation, only when specific conditions are met do we assign the appropriate permissions. When implemented, it's quite detailed. As for password security, right? Regarding password security, we just talked about this username, which is a plain text password. In such a case, when we go to show configuration, the password might be exposed. So, in this case, if all your passwords are in plain text, everyone can see them. Then your user authentication is essentially null. So, we need a way to protect this password. Password protection, protecting the password. Password protection, here there are several types, like type 7, type 5, type 6, type 4, and some others which are relatively common. Type 7 and type 5 are the most common. Type 7, for instance, has a command service password encryption. This one means it can encrypt all your passwords. At this moment, like on R2, oh, R2 is not level 15 just now. For region R, how is it level 4? I think I did something stupid. Did I set the console port? I set, this should enable level 5. This is okay. In this way, I'll go check. I just did something. What did I say? Don't do this operation. This is a bad example. Just now, this thing I demonstrated, I almost screwed myself. You say, setting the console port inside to type. This is a very annoying command. Once you come in, you see the Tarbus mode. But actually, you have level 10 permission, not level 15 permission. You can't do what you want to do. We go to line console 0, where we go, I directly give it a no. I directly give it privilege. Like this, I give no privilege. Enable, I remove this privilege. Enable command. I remove it. After removing. Here there is no privilege, enable command. Now, let's see, I'll check here if there is any username show run. I'll check if there is a username. There is one, right? Password Cisco. I'll type another enable password Cisco. We show run at this time, show run can see enable password Cisco. User, his password is Cisco. I'll add another user like username super admin privilege 15 password Cisco. In this way we can see now I have 3 passwords here, 1, 2, and another enable password. Now we, right here, type this command service password encryption service password encryption. After typing this command, you will find the password encrypted, right? Turns into ciphertext, but actually this kind of ciphertext is not secure at all. I can even crack it without tools. How do we do it? Like this, on my side, like here, I paste it out. Any type 7 password is not secure. Keychain, just choose any, like ABC here. Keystring, key 1, the keystring is behind. You add a type 7, add a 7, paste your key after 7. Then you go to show keychain. What is this? It's restored, right? It's restored. Same for the one below, right? The one below is actually Cisco too. Just now, let's do another one, right? My keychain ABC on my side, key 2, keystring. I copy it down, then paste it in. Okay, show keychain. Right? You say let's do another one. You say let's do another one. I say the username is that CCIE password like CS23. In this way, we go to show run to see this password. Although it looks encrypted here, it's actually not useful at all. This type 7 password is too weak. I copy it down again, copy down on my side. Let's do it again. I go to keychain ABC. In here, key 1, key 3, the key string is pasted on, show keychain. So it's best not to use type 7 passwords, right? So to say this command is slightly better than nothing, right? We should use type 5 as much as possible. Then enable password. Type 5 is much more secure. Therefore, it's advisable to use it. This type of enable password only supports type 7, which is not secure enough, right? We recommend using something like the enable secret command. The enable secret command uses type 5, which uses MD5. And about MD5, this thing can't really be considered encryption anymore, right? It's irreversible. It's a one-way function, impossible to reverse. So this means by using MD5 to hash the password, you hash the entered password and check if the result matches the configured hash. If it matches, the password is correct. If not, it's incorrect. The difficulty of breaking MD5 is quite high. So don't use type 7, preferably use type 5. MD5 is much safer. So avoid using type 7. Use type 5 instead with the enable secret command. Password secret, which uses type 5 for hashing. Besides type 7 and type 5, there's also type 6, which uses AES for encryption. And there's type 4, which some iOS support and some do not. Type 4 uses SHA. For SHA-2, it's 250. It uses SHA-2, which has a longer hash value than MD5. Thus, it has better collision resistance and is harder to crack. In summary, prefer to use type 5 and type 4 and avoid type 7, as it offers almost no protection. Honestly, even someone with a good memory could easily remember it. So, it doesn't even protect against peeking. Just take a keychain, paste the password there, and it's visible. That's how insecure it is. If I leak this keychain, no keychain, ABC, it's gone. Gone. This is the password. Try to use encrypted passwords in configurations, not plain text. When configuring passwords, note that there's type 0, which appears as a plain, unencrypted password. Type 0 means plain text, and 7 means encrypted, but easily decrypted. We should mainly use type 5 or type 4, which are secure. During password configuration, you actually input it in plain text, and the system converts it to a secure hash. This means, even if you set a password, you don't know its secure hash directly. It gets encrypted in the background, and that's why it's secure. You should always use encrypted passwords and avoid any plain text in configurations. No keychain ABC, it leaked out, now it's gone. It's gone. This is about passwords. We should use encrypted passwords in configurations as much as possible. Don't use plain text passwords. When configuring passwords, note there's something called type 0. Type 0 is what we just went to check when we showed the username and password, right? At that time, this place is where the username and password are looking like this. There's a 0, isn't there? That 0 means type 0. So this type 0 means that. This place here is in this area, right? It's here, right? It should be here where we configure a username, CCIE, password CIS101223, and then, in this case, show run. From here we can see I typed a command. Wait a second, let me check this. Was it typed here? Username CCIE. Where's the CCIE account? Where did it become type 7? I typed a command. There's already a CCIE, right? Well then, I'll try another one. Username's CCNA. Then, the password for this is, say, for example, Cisco, CCNA, like this. Show run. Oh, a command is already activated here. It's already on. Service password encryption is on. Is there? Here I go, username. Usernames are CCNA, CCNA. Password, Cisco CCNA. Show run. Now type 0 represents where type 0 means plain text. Plain text is type 0. 7 means it's encrypted, right? But this encryption is easy to decrypt. We should use type 5, type 4 whenever possible. When configuring a password, you always use plain text. What do you type? I think a normal person configuring a password wouldn't possibly set it up this way. You say I need this password to be so much. This password is so much. We just saw it. Which one it is, I don't remember. This password should be Cisco. Oh, the CCIE password should be, I remember the CCIE password is Cisco 123, for example. When you configure a password, you can't say I want to configure a Cisco 123 password. I want to write it like this. It doesn't exist like that. This situation only exists in a certain place, only in this way. Like here, for instance, here I add a username, user, password. The password is that hello. Then at this time, right, we here show run. We can see his password, user1. The password is this bunch of stuff. Now we copy it after. On this R1 above, I directly paste, right? Is it possible? Yes, it's possible. Now I'm on R2. I go to telnet 12.1.1.1. I use user1, password hello, login. Is it possible? Yes, it's possible. So this kind of type 7, type 5, this password, usually you enter it letter by letter. You can't say you set the account password. I guess the password is a 151 AZ100825. It doesn't exist like this. So this type 7, type 5, when you configure it, you always configure it in plain text. When you type the command is to say, when you type the command, it will help you transform it. That is to say, when you type the command, it will help you encrypt. For example, enable. Secret after typing. After typing the plain text password, it will convert it into type 5. It converts it into a type 5 password. It's not like when you're configuring, you say like this for configuration. Username, for example, user2. Then here it is, password. You say at this time you need to type something. Type something like pass CCIE, for example. If you type this, right? You can't do it this way, right? What you need to type is, you need this, you need to go username, user2 secret, pass CCIE. Type it this way. Of course, you say typing like this. You also can't do it this way. When typing, you shouldn't bring that type. When typing, you just use type 0 normally. After typing, it will automatically convert it to an encrypted form afterward. That's how it is. This is about password protection. Then the command authorization is decentralized. In this place, we can move commands from high level to low level. Like we can move a certain command. For example, right now, I show privilege. Right now, I'm a level 15 user. Then right now, I come over to level 1. How did I come out directly? Admin Cisco. At this time, show privilege. Admin Cisco. At this time, show privilege. At this time, you say, can I go show run? Is it possible? No. Then you say, can I enable it so he can use it? Yes, you can. Come in. Enable. Password Cisco, right? Not Cisco. What's the password? So, I log in with a level 15 account to check. Super admin. Password Cisco. Show. Actually, I can't see it. Why not? Because it's like this, so we can only overwrite it. I'll change enable secret Cisco like this. Change it out, right? Going out. Now we go. This time we go again. Admin Cisco. Enable password Cisco. You can come in, right? Now I'm at this level 15 authority. We go privilege. Privilege. Yeah. In this place, he has this command. Privilege. This place has exec and that config. That is, here he has an exec. This is where we have an exec. This means we, not config means we, this prompt service. Inside not config state down that is no brackets, state down command. That is task number or number. You are this privilege. Exec. If you are commanding config here, you own give like this privilege config. You have to configure it this way. This means now this way. This means now this way. Privilege exec. We move it to level 1. We move what command to level 1? We move the show run command. You show run command after typing. We go show run. We first look at show run. We first check this command. He says if you want to type show run, you must first move the show command to level 1. Then move the show run command to level 1. Show run spelled out is show running configure. Now, then I come out again. I come out and then I log in with a level 1 account using admin Cisco. Hey, I copied the wrong password. Admin Cisco over here. We can go show run, right? But while the command can be typed, he only has this command. But you can't show anything. Why? Because your configurations, you don't have any configurations that are level 1 permissions. That is, essentially, you can show the configurations corresponding to the commands your permissions allow. That means you can show the configurations, everything you can type corresponding to your permissions. For example, at this time, show run cannot be displayed, right? You say you want to show CDP neighbor. This command is level 1, right? You can show, you say you want to dir. This command is also not there, right? We need enable level 15 dir. So yes, we can move commands, but this thing, honestly, is quite troublesome. You have to consider many things, like for example, right? If you want to move this command under config mode, you have to move these config mode commands to other levels. You have to consider, you must first move this config terminal command over. If you say config terminal this command, you are not. For example, you say you want to move this, you say you want to move some commands here. You say you want to move this router command. You want to move this router command to level 5. At this time, you move the router command over. You haven't moved this command over. Just this command isn't there. Can you use it? You can't use it, right? So this thing is quite troublesome. So this thing is quite complicated, quite troublesome. Later when we talk about 3A, we will explain in detail. This is that command authorization decentralized. Okay, so with that, Let's take a short break.